video, we are going to have a look at a question. So how to express a vector using arc length parameter. So in the previous video, we have learned about the concept of arc length parameter. If you haven't watched those videos, I have the link in the description, so please watch that. And if you are new to the Expert channel, don't forget to subscribe it. So here they have given the equation, the vector equation with the parameter t, and they have asked to change that parameter to arc length parameter, the equation to arc length parameter. So what we can do is, actually we knew the equation of the arc length parameter, so let's write that first. Now we have written the equation, so s is going to be the arc length, so this is going to be changing because we have taken that t, which is going to change, and here we are going to differentiate that, and after that we are going to find out the mod value, which means in the previous video also I have explained this is going to be the second norm. That's why we have just put it as two lines in both sides. So it's going to represent the mod of, or the magnitude of that vector, or the tangent vector r dash u with respect to du. So how we can figure it out the answer? So let's do the first step now, t naught to t, and we are going to find out the mod value, or the second norm of that vector, the r dash u. So in the previous video also I have explained this ru is simply meant the rt, but for the sometimes they might be confused because of this t, we are using t the triple time, so that's why we have taken as u. So if you change or use the u variable instead of t, you are going to get the r dash, so the r vector of u we are going to differentiate with respect to u. If you do that, you are going to get the value of r dash u. So what we can do is we can directly write down the differentiation or differentiate this ru. So here we actually knew the ru is going to be this value, sine t cos t comma 2t. If you change that in terms of u, you are going to get sine u, cos u, and 2u. If you differentiate with respect to u, you are going to get, if you differentiate sine u with respect to u, you are going to get cos u. Likewise, if you differentiate others, you are going to get some value. Now I have written all those values. Here we have got cos u minus sine u comma 2. So this is going to be the vector, the tangent vector of that rt, the line. We are going to, we have found out the vector, the tangent vector at each point, and simply it's related into u. So here we need to find, the next step we need to find out the magnitude of this vector, because we actually explained that in that line, in the graph, or in that line, we are going to take separate pieces and we are going to find out the magnitude of that piece. Let's say this is going to be 2 centimeters. Likewise, here it's going to be another 2. Likewise, we are going to separate those small parts and we are going to find out the length of each small pieces. So finding out those length of that small piece, we need to, once we found out this one, we need to find out the magnitude of that, so that how to find out this magnitude of a certain vector which is having in the t3 coordinates and the 3 plane in 3D plane. So how to find out? It's very simple. We are going to take the root of all the values, we need to square them. If you do so, you are going to get cos squared u minus sine u whole thing squared, and sorry, this is going to be the plus, we need to add them up, so we are going to get 2 squared, which is going to be 4, and this is going to be the magnitude part of this vector. So once you do that, you can easily solve that. You are going to get cos squared u plus minus sine u whole thing squared, which means it's going to be sine squared u again. So if you simplify that, you can directly write it as 1, so that you are going to get 1 plus 4, it's going to be root 5 du. And if you simplify a little bit, the s would be equals to, if you integrate with respect to u, you are going to get root 5 u, because root 5 is a constant, so you can take it out. You are going to get 1, integration of 1 with respect to u. So here you are going to get u, so u t naught to t. So it's going to be root 5 t minus t naught. So this is how you need to do the sum. So now here they have given to start from the t naught from the point 0, 1, 0. From the point 0, 1, 0. Which means they haven't given the exact t value where it's starting. Let's say it's starting from t naught, but they haven't given that individually, but they have given the total value of sine t. It's going to be 0 when t is equals to t naught. Likewise, the cos t is going to 1 at the value it's going to be t naught. Likewise here, when the t is going to be t naught, the value of 2t would be 0, because they have given a certain point, but they haven't directly given the t naught. But from that you can directly find out when 2t is equals to 0. Let's say if you substitute the value t naught over here, 2t naught is equal to 0, which means t naught is going to be 0. So I'll write it again. So 2t naught is equal to 0. So t naught would be equals to 0. Always remember, here this is going to be, if you are changing the value of t, you are going to get several points in a certain line. And what we have done was, they have given some point. From that we are finding what's the t value. What's the t value? For what t value it's going to get this point. So now you can get t naught is equal to 0. If you substitute here, you are going to get 1. Cos 0, it's going to be 1. Likewise, sin 0, it's going to be 0. So now we have figured out t naught is equal to 0. So what you can write, it is going to be root 5t. So which means s is going to be equals to root 5t. But now the question is to express that line, express that vector r dash t. Here the vector is given in terms of t parameter, sin t, cos t, 2t. But what they are asking is to change this t to s, to represent that line using this s vector. Sorry, x parameter. So how you can do that? So simply we knew the relationship between t and s, and you can directly substitute t is equals to s by root 5 in this equation, so that you can get the whole answer. So sine s by root 5. Likewise, it's going to be cos s by root 5. And this is going to be 2s by root 5. Which means in the beginning of the time, let's say this is going to be the graph. Although this is in the 3D plane, for the simplicity, I'm going to draw it in the two line. Let's say only there are two coordinates, or two planes, two lines, two axes, x and y coordinates. So let's say this is going to be the line now, and let's mark the vector using the t parameter. If you take the t parameter, let's say for a certain t, it's going to represent this value. Let's say this is going to be r t naught. Likewise, if you are taking t1, it's going to represent another point in that line, r. This is going to be rt1, let's say. But now we are going to represent the same line using a different parameter s. This s simply means, let's say this is going to be the t naught. We have started this s from t naught. For when, let's say this is going to be s1, is going to represent this value. But how this value is represented, it's going to take, let's say this is going to be a big picture, or let's zoom it out. So it's going to be like this. So we are going to move from this point to this point, which is denoted by r dash t1. So how we are going to move is, that's the important difference between the t parameter and the s, the arc length parameters. We are going to move every time we are adding s, it's going to move like this. So if you add s1, if you get the s1, you are going to get to this. So it's going to start from when you are starting that, you are going to start at this point, and with that, this vector is going to change that value. And every time you are changing the parameter, the value of the parameter, the s1, let's say 0.2, 0.3, if you are changing, you are going to get different points in that line, which means you are going to move with that line. But here you are not moving with the line, it's actually from center to actually showing up that point. It's something different, and if you are changing the parameter, we are going to take it from this arc wise, from that throughout the line. So that's the simple difference. I hope this video would be clear for you. If you have any doubts, please comment it below. Thanks for watching.